So the question involves simplifying this algebraic fraction. We can recognise that both the numerator and the denominator have quadratic expressions as part of them. So when we want to simplify, it means something's got to cancel. It means we can't just simply cross that x and that x because they're only one term within the three terms on top here, and they're only one term in the three terms on the bottom. To be able to cancel within fractions, it's something that has to be common to all the terms. So something would have to be in all six terms to be able to cancel just straight away. So we've got to look at another technique. Well, quadratics will normally factorise into brackets, and then usually you find with algebraic fractions that one of the brackets is the same, and then you can divide through by that and cancel through and make it look simpler. So we're going to factorise first. So the top quadratic has got no common factor apart from 1 in all the terms, so it is going to be a two bracket factorisation. 2x at the beginning and x, because 2x times x makes 2x squared. We need two numbers that multiply to make 3, both positive, 3 there, and we need a negative. So to make a positive involving a multiplication, we need two negatives. So we're going to have to use negative, negative. We want to make -5 out of the x's, so we're going to need 2 and 3. So 2x times -1 is -2x, -3 times x is -3x. Put those together, you get -5x. It seems to work, so that's okay. We've then got a clue because the bottom quadratic must have one of these brackets as part of its factorisation, otherwise nothing's going to cancel. So x and x at the front to make x squared, so x times x is x squared. We need to make -6, and the answer's got to give us a positive 5x when we multiply out both brackets. So -6 you can make by doing -6 times 1, and when you add those, -6 plus 1, we get -5, so that's no good because we need positive 5. We can also make -6 by doing -1 times 6, and then when we add those, -1 plus 6, we find we get the 5 positive, so it's going to be that combination we need. So x take away 1, x plus 6. And we do a quick check in our heads. X times x is x squared, 6 times x is 6x, x times -1 is -1x, 6x take away an x is the 5x, and positive 6 times -1 is -6. So that seems to be okay. We've both now got on the numerator and the denominator the same bracket, x minus 1, x minus 1. So that means we can divide by x minus 1. And what that leaves us then with is 2x take away 3 over x plus 6. Nothing factorises or simplifies here, so that will be our final answer. We don't need the brackets anymore because it's going to be as simple as possible as it is. But again, with all algebra questions, we should check. So, to check, if we give x a simple value of 2, keep it simple, wouldn't choose 1 because 1 squared is 1, 5 ones are 5, 1 plus 5 is 6, 6 take away 6 is 0. That means we'd be trying to divide by 0, so that's not going to help us. So x equals 2 is the next simple number to use. So when we put x equals 2 into here, then we'd end up doing 2 times 2 squared, take away 5 times 2 plus 3, all over 2 squared plus 5 times 2, take away 6. 4, 8, take away 10 is -2, plus 3 is positive 1. 2 squared is 4, 14, 14 take away 6 is 8. So using 2 we get an answer of an 1/8 there. So we now put 2 in here, and so when x equals 2 in this one, we find we've got 2 times 2, take away 3, all over 2 plus 6. 2 times 2 is 4, take away 3 is 1, 2 plus 6 is 8, so we've got an 8. So because both of these were okay, our check worked, therefore we'll be quite confident that our simplification having the same answer as our original one using a value of x, then we think we've done it okay. Now the next part of this question is asking us to make m the subject. Now m the subject means that we want to end up with m equals and every other letter on the right hand side. So at the moment we've got m in two places, so we're going to have to do something to bring it all to one side and then allow us to move all the other letters back to the other side. Now here we've got two separate fractions, so to do the manipulation it would be much easier to make this a single fraction. So lots of ways of doing that. We need a common multiple on the bottom, so the common multiple on the bottom will be VB. Now to make that VB, I had to multiply by B, so I multiply the top by B, so the numerator by B, so MB. To make that VB, I had to multiply by V, so I multiply the numerator by V as well, so that's going to be TV, and because we've got takeaway, it's takeaway. That equals M take away T over R. We've then got to manipulate this to make it all work out. So the easiest way to do this is times out the denominators. So if I times by R, then that'll end up being R over R, which cancels to 1 to leave that, but then I must multiply the other side by R as well to make it balance. And the same again, if I times by VB, then VB divided by VB is 1, so that'll leave us with that, but I'll have to times this by VB. So basically we end up with R bracket MB minus TV. Now it's really important to do the bracket at this stage because we're going to multiply R by both of these. That then has gone across there, and the VB is going to come across here, so we end up with VB bracket M take away T. Because M is still in two places, we'll have to multiply out all the brackets and expand them so that we can start moving things around to leave the M's on one side, or the terms with M in them. So we end up with, because I want M at the front, so I'll leave M at the front, so it's MRB take away RTV, because we've expanded this bracket, and then it's MVB take away TVB. Okay, so at the moment then we've got a term here with M in it, and we've got a term with M in there. So the easiest thing to do now is to subtract MVB from both sides and add RTV. Adding RTV means that's going to become 0. Taking away MVB means that's going to become 0. And we're left with the M terms on one side and everything else on the other side for the moment. So MRB, so we'll have MRB take away MVB equals, because that's gone to 0, that's gone to 0. So because we're adding this, that makes that the positive, so we'll put the positive first. So RTV take away TVB. We've now got both the terms with M in on the left hand side of the equals, and because we want to be M equals, then we'll factorise the M out so that we end up with a single M as part of this. And in factorising out, divide that by M, you're left with RB, divide that by M, you're left with VB, and there's a takeaway, and that equals RTV take away TVB. I want M left on its own, so I can divide by the bracket, so we can divide by RB take away VB, do it to both sides of course to make it balance, and because that will then make it the same, because the equals means it's the same on both sides, and we end up with M equals RTV minus TVB all over RB take away VB. So that would be our final answer at this stage. We have M as a subject and all the other letters onto the right hand side of the equals. So that would be how we could rearrange that to give us the right answer. Now there are some common factors in these, so we could neaten this up a little bit if we wanted to, but that would be enough to get you the full marks. But we'll neaten it up a little bit. We've got TV in both of these, so it'll be TV R take away B over, and in this one we've got a B in both, so B bracket R take away V. So I'll just neaten it up a little bit, but M equals all of that. So rearranging, again, you're looking to get M as a subject. You've got an algebraic fraction here, so make it a single fraction. In doing that, that then allows us to multiply the denominators across, which then allows us to get a single line with an equals, and then we can do the manipulation in the opposite operations to allow us to get the M onto one side, factorise out to leave M on its own, and then divide through, gives us our final answer. So that's a run through of simplifying an algebraic fraction and rearranging to make something the subject.